Okay, so this is obviously lesson 2 here, Maya underscore 2, and what we have is simple polygonal boxes. You can create those by going to create polygon cube. So I have one that actually has a face that's been deleted, and here's another one right here. So real simple stuff, and we're going to go over the understanding of UVs. But first I want to talk about some display settings you can put on here. If I take any one of these cubes, I can go ahead and come over here to display polygons, and we'll pull up that little display thing again here. And you got a couple options on here. You do have something called backface culling, which I can turn on and off with the piece of geometry selected. Now, it's common in games, actual, for instance, the Unreal or Unity engine, that when you have any piece of geometry you bring in to the program, if it is seeing through to the opposite direction of a normal, it'll come in as transparent. So you can see if I were to take this piece of geometry into Unity, this is how I would actually see it, because it only displays the normal facing up direction. And of course we know that these normals, like a porcupine, are sticking out, but anything behind it is actually seeing through. So to kind of not have the double-sided default that Maya allows, you can turn on backface culling by taking a piece of geometry and turning it on and off and so forth. There's a couple other options here: keep wireframe, keep hard edges, and so forth. So we have all these. I talked about this before. We have our face normals, right? So if I go to take the geometry, you can see we got the face normals. We also can turn that off and click on vertice normals, and I'll go ahead and turn that off. And then you have this a couple other things here. You have this option for border edge here. So border edges are pretty cool. If I go ahead and click on that, that allows me to see a physical border by the reality of a dark line. So you can see if I kind of take a look around the corner, you can see this has a lot thicker line than these here. This allows you to know when geometry is not actually merged. Again, this is a modeling technique used a lot, but we're not going to be using it too much. So I'm going to go ahead and turn that off. So again, I'll come over here and then come to the border edges and turn that off by clicking it again. And then we have this thing called texture border edges. So I'm going to go ahead and click on that. And click, and I'll grab this guy as well and just go ahead and say texture border edges. And if you take a look, the thickness of the line is now based on the actual UVs. So the UVs are the actual 2D layout of a 3D model, sort of in the same way that the globe Earth is actually unfolded and flattened out, and the proportions are a little bit different because you flatten the image out onto a 2D plane. And in doing so, you can see Antarctica is huge and so forth at the bottom of the map, and Greenland, Iceland, or their proportions are not how they would be in real life based on a globular model. So as you can go ahead and see here, we do have creases here. Again, this is not it has nothing to do with the reality of this being a border edge, meaning an open face here, but it has to do with the texture borders. So we're going to go ahead and open up under Windows. We're going to go to Modeling and go to UV Editor and take a look. Now this thing is brand spanking new in the latest versions of Maya. They've really done an overhaul on the UV layout. They have this ridiculously huge UV toolkit. And again, this is under Windows, Modeling Editor, UV Editor. And you can see if I go ahead and click on any one of these pieces of geometry, we have what's commonly considered to be the 0 to 1 space. 0 to 1 in the Y, 0 to 1 in the X. This is a perfectly square, it's the same proportions unit here. Now, a lot of these, some advanced models used in Hollywood will actually use up multiple UDIMs, and they'll have a series of little squares here. But ultimately, this is a repeat of what is kind of placed in the 0 to 1. Ultimately, it's imagine if you were to assign a perfectly square texture like 512 by 512 or 1024 by 1024 or 2046 by 2046, basically, or should say 2048, sorry. Image on here, and that's what we do. We create the textures that are to apply a texture. So if this was supposed to be kind of a sort of like a I don't know, possibly like a texture of a wrapping, present wrapping, you'd have some kind of decor or whatever in a Photoshop file that was a perfect square image, and it would get assigned to the actual geometry, and you would see it represented here. So as you can see, this is pretty simply already laid out by default and unfolded. In the same way you would unwrap a box, if you were to cut a couple slits in it and it was made of cardboard or something, you would unfold it like this. So the UVs technically are already laid out for you. And what we're going to be doing is I want you to, again, this is not a modeling class. This is a class of how do we take a model and prep it for, proper UVs. UVs are the foundation to any texturing. Any work in regards to texturing, if you screw up the UVs, you have screwed up the next whole, all the way to the end of the pipeline. It's going to look terrible. You'll have all types of strange things happening, such as distortions and all that. But just be aware of that. Now, it's hard to tell what exactly we're dealing with here, so let's go ahead and assign actual material to this. So I'm going to take this actual cube here. You can see it's already assigned to a Lambert 1 by default. All things in Maya are assigned to a default material. So what I'm going to do is just take this piece of geometry, right-click, and just say Assign New Material. And it's going to pull up this Assignment New Material, and I'm going to go to Maya, and let's just go ahead and choose a typical Lambert. Let's go ahead and choose that. Lambert's just a default material here. So I can see that you can see the color. If I go ahead and take a look at it, I can change the color to something a little bit darker or brighter. And I can change the color in here, make it red. But currently there is no information other than color being plugged into what we see. So I'm going to take the color checkerboard here, which is under the material. Again, anytime you kind of don't get this, just grab a piece of geometry, grab the Lambert material and the attribute editor, which obviously is this little button right here, and click on the checkerboard and go to File. So under Image Name, which is the next plugin, I'll just go ahead and click on that. And I'm going to choose under my class files, and you'll have to navigate via here to your DMA 375 class files, reference materials, and you'll see this UV matte JPEG here. This is a 1024 by 1024 map. I would have preferred a 2048 by 2048 map. But it just has this multicolored reality from red to purple here. And this kind of gives you an idea, spectrum-wise, where it's at. It's a perfect square image. I'll go ahead and hit Open. Now, I'm not seeing it displayed here, even though it is assigned. So I'm going to go under Shading and turn on Hardware Texturing. And now you can see what's going on. If I click the piece of geometry here, I'll go ahead and make some room here. And I'll pull over that actual tool set here. Now you can see there's a desire for this to be docking. So you can physically dock this by kind of dragging it and putting it like right here on this line, like that. And then you can go ahead if you want to and close out these shelves. If you wish, I'm going to leave these shelves in for now. I'm just going to kind of click here and just kind of make some room. I'm going to turn off my tool sets here. Actually, I'll leave my tool sets here. And I'm going to pull my outliner out so you can see I can kind of drag that out and move that off to the side. So I have my UV toolkit, which is obviously good to go. I have my UV, this is basically the UV editor, and over here in this window is the actual geometry seen in the 3D perspective view. So you can see the actual representation of where everything's at. And you'll notice that when we come in here, it looks a little bit bright. It's hard to see these lines here. So what I usually like to do is I'll come over here to the image, and it's already set to dim. Not sure why it's not working right now. It's set to dim a little bit, so it's kind of dimming the color a little bit. So leave it as like that. If you right-click, you can see I can right-click and hold and drag over to my right the UVs. So I can grab a UV, and it's this green. Vertices are basically anything that is basically golden colored. So for instance, if I go in my 3D view, right-click and say Vertices, I can grab vertice, and it should be in the form of a little yellow dot, as you can see there. Whereas a UV is something that I can move around in the UV editor, but I cannot grab and move around, obviously, in 3D space. So only vertices can be moved around in 3D space. But you can see if I go ahead and take a look and grab an edge here, the edges correspond to what is going on. So for instance, I come over here, and you'll notice in the UV editor, I have two edges selected. I just select one, there's two edges, because this edge and this edge are the same thing. They're overlapping here, but this edge is the same as this edge. Okay, so if I click on this edge here, you can see it's just one edge in 3D space. So I'm going to right-click and go to UVs, and I can change these. So for instance, if I kind of move this around, you can see it's giving me a nasty distortion of what I would want, which is perfect squares here. The whole purpose of this UV layout is to make sure that you don't have any odd distortion in comparison to what's in your UV space versus what's in your actual 3D space. So for instance, if I were to grab these two UVs here and move them up, obviously there's something wrong because there's rectangles here as opposed to perfect squares. But over here, everything is actually, fine. So this should be perfect squares. These should be perfect squares. And all of your UV shells, and this is considered a UV shell, should be within the 0 to 1 space. So if I right click and grab these UVs, I can move them around, and you never want them sticking out like here outside the 0 to 1 space. They should all fit into the 0 to 1 space, because what you're going to be working on eventually is a bunch of square files in the form of what's called maps, and those will be what you are going to be assigning to this scene. So you can see if I take this and scale this down, again, I'm using the scale, I'm right-clicking, grabbing the UVs here. Now, under my UV toolkit, there's a couple options here. You can see I can do vertice selection, right? I can come over here and choose edge selection, and here's face selection. Obviously, I can scale this, but I'm scaling UVs really. And then you have this really cool thing called the UV shell. So anywhere I select, it's a UV shell. And there could be multiple shells. So I'm going to go and use my translate, rotate, and scale, and I can move these around. So you can see what's going on. If I were to take a look into 3D mode, you can see as I get closer to the object, this 3 is getting blurrier and blurrier. It's important that we keep a consistency of similarity between each squares. Like this square should be the same as this square roughly. And the resolution should be not blurry to us. So, for instance, if I go ahead and grab these UVs and really max out the UV space here, which is what I definitely want to do, because eventually this will probably be assigned to something like a 2048 by 2048 map. Now that I've scaled it up and I take a look at it in 3D mode and get really close, and it still remains a sharpness under the 7. It's a little bit blurry, obviously, because it's a 2048 by 2048 image, but that's has a big play, and especially when we get into using creating assets for virtual reality, because you in virtual reality are so close to the object that it ultimately is, it'll look blurry to you because you're literally right there in virtual reality. Say if you're walking around in the Unreal 3 engine or something, or I'm sorry, Unreal 4 engine. So again, I can grab the UVs and I can move them around, use my translate, and you can see all types of things. I can also come in here and grab an edge, like for instance this right here. You can see I grab this edge here, and I can go ahead and split this. And the tools you want to use are in the UV toolkit. So there's a lot of options here. You can see a transform. If I go ahead and grab, let's see if I just grab these UVs again, or I can just go ahead and click on the shell, right? So here's the shell. It's my shell button. I can go ahead and rotate this. So I can move it 0.1 units over if I want, up and down, which is cool. And then you can also do, you can do also types of things with snapping. You can rotate, so I can rotate this 90 degrees if I wish. And I can also come in here and do flipping. So flipping is usually needed when your numbers are inverted. For instance, if I do a flip in the U, the numbers are now wrong, and that shouldn't be the case. They should actually be reading, this shouldn't be reading a backwards F, so that means I need to flip it. Sometimes you can flip it vertically, right? Or, horizontally. So I can go to U and V. So I'm going to keep doing this until the numbers come out facing forward like that. And what I like is not to have the numbers upside down. I want them facing directly in relation to where I should be as far as the ground plane. Right? I'm facing, standing up, looking down, and that's kind of important. Now, we're going to talk about how we can use different mapping techniques to remap our UVs. Currently, we have a UV set in here. So there's a whole bunch of options here, and then you come to cut and sew. This is where you do the cutting and the sewing. So I can go ahead and grab this edge here, and you can see we have that thick border because we turned on the actual texture border edges. I'm going to click on this little guy right here, and I'm going to say cut tool. I'll just say cut. And what cut does is you can see now we have a division here. And now if I come over here and jump in, I'll kind of scroll back up to the top, and I'll click on the shell button again, and now I can see I can grab certain shells and move them around, and I can rotate them and so forth, which is kind of cool. So a UV shell doesn't necessarily have to be this, but if I right click and go to edges, you can see I have the corresponding edges here. So let's say if I wanted to, I can take these two edges, I can select them, and I can do a little sewing. So I just did a cut, now I'm going to do a sew. So I'm going to come over here and say sew, but watch what happens if I sew it. It merges it halfway point, and it looks nasty. What I want to do is what's called move and sew. Move and sew is the most common tool that we use here, and for some odd reason, I don't see the tool move and sew in here. Maybe it's further down. Yeah, they don't seem to have it on here, which would be kind of nice. So to find the move and sew, you can go over here to cut and sew, and the pull down menu, you can do move and sew. I'm guessing it's somewhere over here. I'm not seeing it. So again, I can do this, and it's going to move and sew. It'll keep the heavy object. In this case, these are probably all the same. But the bigger object in size will actually stay put, and the smaller object will be moved over and sewn together. So watch as I do this. I'll do move and sew. And what happened was it took this piece and moved it over and kind of sewed together. So now we have a T, and it's perfectly plausible and usable as long as we make sure that this gets squeezed into the 0 to 1 space. I don't want to necessarily come in here, and I'll use my plus and minus keys to make my scale go up and down. I'll put this to scale. I don't want to do this, right? I don't want to do this. You can see the difference. These are rectangles now. We don't want rectangles. We want them to be perfect squares, and we want the numbers or letters to be facing outward and straight up and down like that. So again, you have to, the biggest rule I always say is no overlapping UVs. So for instance, if I go over here and grab this UV and I overlap this here, you'll see we start to get this interesting shading that kind of warns us and says you're overlapping UVs. Sometimes in game design you actually overlap UVs. For instance, areas that you want to repeat. It's always about optimizing UV space. For instance, usually the side or the part of the ear and the side of the cheek can be repeated. But anytime you see this overlapping color, you know you're in trouble. So again, I can come in here and grab this edge here, and I can do another cut. So again, I can come over here and do cut. You can also do this from the pull-down window, cut and sew. So if you want to just do a cut, there it is. I'll go ahead and grab the UV shells, right-click UV shells, grab a UV shell, go to Translate, and move it around, and then maybe I'll choose this edge here. Now, I want you to take a look at this. These two edges here, this edge and this edge, are parallel, right? If I go ahead and do a move and sew, watch what happens. It actually rotated it for me. Isn't that nice? It actually rotated it around, but sometimes you actually merge it and it'll just stay put where it's at, which is dangerous because it's still overlapping. So again, if I just take the UVs here and I'll move them, you know, it might sew it like that, which is not what you want. So I like to prep this stuff by actually kind of rotating it. So I'll grab the UVs and I'll come over here to rotate. And let's go to rotate here. There we go. And I'll just go ahead and rotate this 90 degrees or 180 degrees, put it up here. And I like to correspond the edges. So you can see the edges are matching now. You know, if I were to kind of move along the edge here, you can see the two edges there. And again, I'll grab these two edges right here. Let's see here. There we go. Grab those guys. And we'll do a move and sew. So a sew just merges them together like that. Sometimes you want to do that. And then you have the move and sew. It just moves one piece over and doesn't actually distort the actual geometry. So again, there's many different ways to, you know, do this and kind of lay it around. You can see the UVs kind of changing here. But the big thing is I like to have the UVs facing at me as best as possible and have as least amount of viewable seams as possible, which will play a part later on. So you can see we have the UV texture seams on, and I can see in dark lines that this could be an issue if I don't use what's called projection-based texturing, which we're going to get into in Substance Painter, and it'll give away that there's a crease or an edge here. So that's something to kind of play. Is you always want to hide away from the facing. If you're the audience and you're only going to render this cube from here, you might want to change this edge here and make it seamless. So for instance, if I can go ahead and see like this edge here corresponds to this edge. So what I'll do is I'll take this edge here. I'll go ahead and say cut. And now I'm going to go ahead and take the UVs, right-click UV shell, grab the shell, move it over here, right-click edge, grab the edge here, and then do a quick move and sew. And now you can see that we don't have a seam here. So if I go ahead and move all these together, it's going to be more good to go and less obvious if we don't use projection-based texturing, that there's no seam there and the audience isn't going to pick up on the inconsistency. So again, lots to play with in regards to tools. In the next lesson, we're going to talk about automatic mapping, cylindrical mapping, all this type of stuff. I'm really going to go into a few of these. Again, I don't want to this is more of a texturing tutorial, not UV layout. Usually modeling classes will teach you the UV stuff if you haven't heard it already. But it's good to have a basic foundation to understand what UVs are and how important they are to be well optimized. Like for instance, in this scene, we would never leave this as the UV layout. We would try to take this and scale this out to fit as best we can. And one of the ways you can do that is this really cool tool called the layout, which squeezes it into the 0 to 1 space without having it go out all the way. So I can do layout, and you can see it fitted it so beautifully. If I zoom in, it may look like it's on the outside, but it's just right on that line. So it optimizes the space as much as possible. You want to get as much resolution as you can in this image. You may only have a 102048 by 102048 map, and if it's not, if there's not enough UV space covering all this beautiful real estate, you will actually have a blurry image. So consistency of all of these squares being roughly the same size, not always, but usually roughly the same size, and all facing out and looking correct, and their resolutions holding up when you walk up to them, right, without getting blurry, is very, very important. Like for instance, just one last thing before we close up this. I'm going to go ahead and take this and cut this. So I'm going to go ahead and cut this UV space. I'm going to right click, go to UV shells, grab this UV shell, and I'm going to go ahead and just do an example of what happens if I make this really, really, really small comparison to this, right? So do you see the lack of continuity of sharpness and resolution, so to speak? Here, this A is very, very sharp, whereas this A is very, very blurry. So you'll have this area of your scene that's extremely, extremely blurry. This area will be nice and sharp, and that weird inconsistency will tip your audience off to some very bad UV work, very bad texturing work eventually. It'll ruin your day. So again, we're going to go over how to lay out these in different techniques and how to lay them out in an optimized way in the next lesson.